Okay, new video 8.5. We're doing trapezoids and kites. Now these are a little bit different. They do not have a lot of the same properties as the parallelograms, the rectangles, or the rhombuses, and you'll see that as we go through the definitions. Okay, a trapezoid. A trapezoid is a quadrilateral, so it does have 4 sides, but it has width exactly 1 pair of parallel sides. So either the top is parallel to the bottom or the left is parallel to the right, but not both. Okay, the bases of a trapezoid are always the parallel sides. So whichever sides are parallel are considered the base of the trapezoid. The base angles share the base sides. So each parallel sides have base angles. So parallel sides will touch the base angles. And I'll show you pictures on that when we get down to the theorems that explain this. Okay, so the legs of the trapezoid are the non-parallel sides. Remember, we only have one set of parallel sides, so if you're looking at the sides that are not parallel, those are the legs of the trapezoid. An isosceles trapezoid is a special case of a trapezoid. That just means those legs are congruent. So the non-parallel sides are going to be congruent on an isosceles trapezoid. And a kite is a special quadrilateral. Okay, it still has 4 sides, but it has 2 pair of consecutive, remember consecutive means in a row, consecutive congruent sides, and again we'll see pictures below that you can see what this means. But in this case, our opposite sides are not going to be congruent as in the past. Okay, so if you look at example 1, show that CDEF is a trapezoid. Now, the only way we can really show that it is a trapezoid is to prove that there's only one set of sides that are parallel. And again, if we're on a coordinate plane, to prove parallels, we need a slope. So if we do the slopes, and again, remember slope formula, y2 minus y1 over x2 minus x1. So if I take DE, which is this top section here, and I find the slope there, I'm going to go y minus y over x minus x. I get 1 over 3. If I do the bottom now, because I'm looking to the opposite side, C to F, I'm going to go 2 minus 0, 6 minus 0. I'm going to get 2 over 6 or 1 over 3. So we have one set of parallel sides. Okay, now if we go the other way and we do DC or CD, we're going to go 3 minus 0, 1 minus 0, or 3 over 1. And then if we go to the other side, EF, we're going to go 4 minus 2, 4 minus 6, 2 over negative 2, or negative 1. So not parallel. So only one set of parallel sides means it has to be a trapezoid by our definition. Okay, now it says suppose the coordinates of point E are 7, 5. What type of quadrilateral would it be? Okay, so we're taking point E and we're moving it to 7, 5. Okay, so if we do the same thing, we're going to find both DE and CF again. So DE, we're going to do 5 minus 3 and 7 minus 1. So that's still going to be our 2 over 6 or our 1 over 3. Again, our CF is going to be 0 minus 2, 0 minus 6, negative 2 over negative 6. And 1/3. Now I just switched it from that, but this is really the same thing. So we have one set of parallel sides. Okay, so now remember we've changed one of the coordinates E to 7, 5. So CD is going to be 0, minus 3, 0, minus 1, and again I just switched them around, but we're going to get the same thing, negative 3 over negative 1 or 3 over 1. And now here's the set that's going to be affected. So EF, new slope, again we're changing the point E, so 2 minus 5 over 6 minus 7, so negative 3 over negative 1 or 3 over 1. So we have one set of parallel sides. So in this case we have both sides being parallel, so in that case that would be a parallelogram. Okay, if we take a look at the first theorem, if a trapezoid is an isosceles, each pair of the base angles is congruent. So here's a good picture for showing you the vocabulary up above. Here's the sides that are parallel. If it's a isosceles trapezoid, the two legs are congruent, and then here's the base angles. These two touch the top, these two touch the bottom. So if it's an isosceles, angle A is going to be congruent to angle D, and angle B is going to be congruent to angle C. Okay, bottom, the last two, if a trapezoid has a pair of congruent base angles, and again this is the converse of this one, then it has to be an isosceles trapezoid. So if A and D match or B and C match, then you know you have an isosceles trapezoid. Last thing, again, we're going to talk diagonals, so you know it's an isosceles trapezoid if the diagonals again are congruent. So if we measure kitty corner to kitty corner, AC has to be congruent to BD. Okay, second page. Okay, example 2, a shelf fitting into a cupboard in a corner is an isosceles trapezoid. Find the rest of the angles. Okay, first of all, we know base angles are congruent. So we know that angle K has to be the same as angle N. So measure of N has to be 50. Okay, we know that K and L are consecutive interior angles from our other chapter. Because remember, if we have two parallels, the two inside angles have to be supplementary. And again, remember that equals 180. So we know 180, take away 50 is 130. So angle L has to be 130. And we know that angle L is congruent to angle M because they are base angles. So the measure of angle M has to be 130 also. Okay, midsegment theorem. The midsegment of a trapezoid is parallel to the base, and its length is half the sum of the lengths of the sides. Okay, it sounds really complicated, but it's not. You pretty much take the top and the bottom and divide by 2. But we'll fill in the thing, and then I'll show you with numbers. Okay, so the midsegment says if MN is parallel to AB, and MN is parallel to DC, so pretty much is the middle, parallel both to the top and the bottom, then MN is 1/2 of top plus bottom. The other way you can write this is just top plus bottom cut in half. Okay, so our example here is pretty simple, top and bottom. So pretty much all you do is 16 plus 9 and cut it in half. So the length of MN, or the midsegment, is 12.5 inches. Okay, if we look at the last couple of theorems, now we're talking kites. Okay, a kite is a kind of a different animal altogether. It has, remember, the definition said it had two pair of consecutive congruent sides. So that means 2 in a row are congruent, 2 in a row are congruent, but they are not opposite one another. And then what happens is the I guess we'll do that in the next one. I was going to talk about the angles. But let's do the diagonals first. The diagonals here are always going to be perpendicular. So again, there will always be 4 right angles in the middle of a kite. So that means that AC, and remember upside down T means perpendicular to BD. Okay, and then the angles. There is always one set of congruent angles on a kite, and it is always the set of angles that are between the non-congruent sides. So B and D are not going to be congruent, but C and A will be because they're between the sides that do not match. So angle A will be congruent to angle C, but angle B will not be congruent to D. Okay, so for the example, find T in the kite below. Again, these are the non-congruent sides, so angle T is going to be the same as angle R. So angle T will be congruent to angle R. Alright, we know that 4 minus 2 times 180 has to be 360 interior angles. So we can do 360 minus 70 minus 88. We get the measure 202, and then remember that covers both of them, so we have to divide by 2. So each of the angles is 101 degrees. Okay, that should take us through 8-5.